Now, let's get to the basics of stoichiometry conversion. Let's use mole to mole, one of the most simplest stoichiometry conversions because it's just basically balancing. Let's say how many moles of carbon dioxide would be produced when 3 moles of C2H6 is used. Using the chemical reaction combustion, we get the formula C2H6 plus O2 yields to carbon dioxide plus water. Now, of course, before we convert 3 moles of C2H6 to mole of CO2, we need to balance the formula. So, of course, you get 2 C2H6, 7O2 yields to 4 CO2 plus 6 H2O. This is the balanced chemical formula. Using the conversion of 3 moles of C2H6 times, we use the multimole ratio, which is 4 moles of CO2 per 2 moles of C2H6. So we of course cancel, then multiply 3 times 4, we get 12 divided by 2. The final answer we get is 6 moles of CO2. Our final answer being, for if 3 moles of C2H6 is used, we get 6 moles of CO2. Now, this is a bit more difficult but still simple, which is mole to mass or mass to mole. So let's say how many moles of H2, let me put mole, would be produced if we use 18.0 grams of C2H6. Using the same balance formula for the simplicity of this video, we put 18.0 grams of C2H6 multiplied by 1 mole of C2H6 over the molar mass of C2H6 being 30.07 grams per mole, or we could just put grams of C2H6 now we of course cancel, so if we cancel this, we get we get 0.59 mole of C2H6. Now, after we get 0.59 moles of C2H6, we do the mole to mole ratio. So basically, like I teach a while ago, 6 moles of H2 over 2 moles of C2H6, because every 2 moles of C2H6, 6 H2O is produced. Now, of course, we cancel mole C2H6. We multiply 0.599 to 6 and over 2. Oh, wait. This is not 0.59. It's 0.49. My mistake, sorry. 0.44999. Oh, wait, no, I'm correct, sorry. I'm correct. 0.59. Using the multimole ratio, which I just showed, Cancel, cancel. We get 1.08 moles of, wait, let me make sure you guys see this. We get 1.08 moles of H2O if we use 18 grams of C2H6. We produce 1.08 mole of H2O following the sig fig. And I want to remind you guys, or like give you a tip. Just remember, mass to mole always goes mass to mole to mole. Basically, it's just mass, then you get the mole, then you get the mole. You'll see it if you understand. Now, using the same balanced chemical formula again, we are going to talk about mass to mass, the most common stoichiometry conversion using the same balance formula. So, how many grams of CO2 grams will of CO2 would be produced if we used 15.0 grams of C2H6? Using on what we learned, we convert the mass to moles. Of course, using the molar mass, so 15.0 grams of C2H6 times 1 mole of C2H6 over the molar mass of C2H6 being 30.07 grams of C2H6. We cancel. We of course get the same answer as a while ago. We got 0.49. Wait. Yeah, we get 0.49, 0.4999, sorry. Moles of C2H6. Now if we remove all of this, move this up. So now we use the mole to mole ratio, of course, which is every 4 moles of CO2 is produced, we use 2 moles of C2H6. Sorry for my bad handwriting. C2H6. We cancel the moles, and we get the answer of 0.9098 moles of CO2. Now we move this up again. We are running out of space, I'm sorry. Now, this is the last step. Remember a while ago where I put moles over molar mass? This time, since we're converting to grams, we need to multiply this by the gram of CO2, which is 4.01 grams of CO2 over 1 mole of CO2. Now cancel and cancel. We get the final answer of 43.9 grams of CO2. If you did not notice, the reason why we always divide is to cancel out the top, so we get the final answer of grams. Basically, like a while ago when I showed grams to moles, we of course cancel out the grams, and mole to mole we cancel out the mole, and we get the mole that we need, and so on.